Welcome to today's video lesson, Unit 5.4b. Today we are graphing systems of inequalities. So we know that a linear inequality, when graphed into variables, has shading that represents all of the possible solutions. Okay? Now when we have a system of inequalities, that means two or more inequalities graphed together. Okay, and the shading solution for systems would be where they overlap. Okay, so if you think back to a regular system of equations, you're looking for where do they intersect. So we're essentially looking for the same thing here. Where does our shading intersect from two or more inequalities? Okay, we're still going to use the above and below the line method to shade, and we're looking for the region where the arrows from each line are pointing towards one another. Okay, so when we actually get into a graph, I will show you more of what that means. All right, so as always, anytime that we graph, we want to make sure our inequality is in y equals mx plus b. And again, we are going to graph these lines on the same coordinate plane. Okay, we're only going to shade one time at the very end for our final answer. So before we do that, we need our arrow system to determine if we're going above or below the line. Okay, so let's take a look at this. So I have two equations. They both happen to be in slope-intercept form already. Okay, and I am just going to color code these. Okay, so I'm going to begin with my red line. Okay, we're starting at 4, and we're going down 2 over 1. Okay, so remember when we graph inequalities, we have to refer back to the symbol for two things. The first is a dotted or solid line. So in our first equation, this is dotted because it is not equal to. Okay, and then we also want to use that symbol to determine if we are shading above or below the line. All right, so we are actually above the line here because this is greater than. So remember our little trick, we draw arrows to point above our line. All right, and we're going to leave it like that for just a minute until we graph our second equation. All right, so putting our second inequality on the graph. Okay, we have a y-intercept of -2 and a slope of 1. Okay, so this symbol is telling me my line is solid because it's equal to. And it says less than, which means I should shade below my line. So I'm going to draw my arrows here pointing below. All right, to determine where I should shade as a final answer, I'm going to look for the region where the red and the blue arrows point towards each other. And I see that over here on the right. Okay, so the blue arrows point down and the red point up. So this is my shaded region. Okay, and that would be my final answer for this system. Okay, that wasn't so bad. All right, let's try another one. Okay, and again, I am going to color code these for you. All right, so my first equation, that's in y equals mx plus b, has a y-intercept of 1 and a slope of 1 as well. Okay, my inequality symbol says that this should be a dotted line. Okay, and in addition to that, it is greater than. Greater than means we point above the line. Okay. All right, so now my second equation, we have to remember what that looks like. Y equals a number. Okay, we can forget for a second that it's an inequality. Just y equals a number. That should be a horizontal line. So here is y equals 3. And the symbol tells me that it should be solid. So I have a solid horizontal line here. Okay, and less than or equal to. So we are looking to shade below this line. Okay, all right, so now take a look at your red and blue arrows. Where are they pointing towards each other? Because that is your shaded region. Okay, and that occurs right over here to the left. Okay, so we've already seen graphing inequalities in 2 variables. Now we're just putting another one on the graph with it. Okay, so it's not too much new skill today. All right, let's continue to crank these out. All right, so my first, up 1 over 2. And I like to extend these on the graph. All right, so this is a dotted line. All right, and this is greater than, which is above. Okay, so that one's done. And now my second line. Now we see that these have the same slope. So I should make sure that I get parallel lines. Okay, this one is also dotted. Okay, and it is less than. So I'm looking to shade below. Okay, so remember, you're always looking for the overlap in your shading. That's how we get a solution. Well, do these 2 arrows point towards each other? Will this shading overlap? And if you're having a hard time visualizing it, you can go ahead and shade each line individually. Okay, if you have 2 colors, that's even better. So I shaded these, and the shading does not overlap. So no overlap means no solution. Okay, because remember, a solution has to satisfy both of these equations, and none of the red points will satisfy the blue graph and vice versa, which means we have no solution. Okay, so this one was a little bit of a special case. All right, so I can tell already from my equations that these are horizontal and vertical lines. So here is -1 on my x-axis. That has to be a vertical line. It's going to be solid because my inequality says that it is equal to. And I want all of the values that are less than -1. So remember, for a vertical line, it's not really above and below. So we're just kind of thinking of it like a number line. So where are all the x values less than -1? It would be to the left side here. Okay, and now y equals -4. Okay, so that is a horizontal. This one is also going to be solid because it's equal to. And this one says above. So pretty obvious for a vertical line, or for a horizontal line, I'm sorry, where above is. Okay, so where are the arrows pointing towards each other, or where do they point towards the same section of the graph? It's over here in the top left square. Okay, so that would be your shading. All right, we're going to do a little working backwards here. So I'm going to label these equations 1 and 2. Label these lines, okay? Because we're trying to work backwards and get the system that created this graph. All right, so line number 1. Okay, the first thing that I see is that it's dotted. So that tells me that it's not equal to. Okay, I also see it has a y-intercept of -2. And I bet that means that I can also count the slope. It goes up 1 and to the left. Up 1 and to the left. Okay, so that means my slope is -1. So also from this first line, if I put my pencil down and I draw an arrow to the shading that's there, I can determine if it's above or below the line. So where am I pointing arrows? My arrows are pointing above. And I know above means greater. So I just found all of the pieces of information that I need to write this equation. So y is greater than -1x minus 2. Okay, that is inequality number 1. We're going to do the same thing for inequality number 2. All right, so again, this is dotted. So we know not equal to. Okay, and I'm going to try and find my y-intercept and my slope. So this one is at a +2. And now I'm looking for another point that my graph goes through so I can count the slope. And I see it down here. Okay, so I'm going to count 1, 2, 3, 4, 5. So it's down 5 and to the right 1. So it's a slope of -5. All right, and then the last thing I want to do is point to the shading. So I'm going to draw arrows that point to the shading. And where am I pointing? This is going below, which is less than. Okay, so again, I have all the information I need. So y is less than -5x plus 2. Okay, and that is the second inequality that is graphed here. Okay, so that's how we work backwards. All right, the last thing that we want to work on are some word problems. Okay, so Emily wants to buy turquoise stones on her trip to New Mexico to give to at least 4 of her friends. Okay, the gift shop sells stones for either $4 or $6 per person. I'm sorry, per stone. And Emily has no more than $30 to spend. So we want to make a graph to show what her possible purchases are. Well, in order to make a graph, we need some equations. Okay, so Emily has $4 and $6 stones. So I know that these are my variables because I looked at the graph. I have been provided a pre-made graph, and the x-axis says $4 stones and the y-axis says $6 stones. Okay, so I'm going to try and use a table here. Okay, like we do substitution and elimination. So I see that Emily wants to give presents to at least 4 of her friends. Remember, at least is a turnaround word. Okay, so that means greater than or equal to 4. And she has no more than $30 to spend. So less than or equal to 30. Okay, so this is money, this is friends. All right, so we're going to make sure that we keep all of the dollar amounts in our second equation, okay, which is $4 for the $4 stone and $6 for the $6 stone. Okay, so that means that this other equation has to just be variables because there are no more numbers in the problem. All right, so to graph these, you could make a table of values, you could use slope-intercept form, you could use x and y intercepts. Okay, so for my first equation, I can very easily solve this for y. Okay, so my y-intercept is 4, and this goes down and to the right. Okay, it's a solid line because it's equal to and greater than, so we're going to shade above. Okay, my second equation. All right, so I am at a y-intercept of 5, and we're going down 2 and to the right 3. Okay, this is also a solid line because it's equal to, okay, and less than, I should shade below. Okay, so where am I going to put my shading? The 2 arrows point towards each other in this region. Okay, so it asked me to list 3 possible solutions. So remember, solutions come from inside the shading. Okay, so I have chosen 2, 3, 3, 2, and 4, 1. So what do they mean? Okay, that means 2 $4 stones and 3 $6 stones. Okay, that means 3 $4 stones and 2 $6 stones. Okay, and last, okay, now there's a couple other solutions that are inside the shading that you could have chosen also. Okay, and you want to make sure that when you list the possible solutions that you identify what that means in the context of the problem. So like I said, 2 $4 stones and 3 $6 stones. So in addition to identifying the ordered pair, okay, you want to put it back into the situation. Okay. All right, and we've got one more to look at. So in 1959, NASA wanted astronauts who were at least 5 feet 4 inches, but no more than 5 feet 11 inches tall because of the limited space inside the Mercury capsule. They were to be between 21 and 40 years of age. Write and graph the system of inequalities. Okay. So we're talking about height and age here. So I can make my X height and my Y can be age. And now I want to write some inequalities. Now, there's not really totals happening here, and it doesn't seem that the height and the age information are linked to each other. So it seems like they're going to be separate equations, meaning it's going to be just the X in one equation and just the Y in another. Okay, and I'm also noticing, especially when they told us about the age requirement, they use the word between. And between kind of makes me think of a sandwich inequality. So remember when we did compound inequalities and we wrote them with our variable in the middle? So I want to talk about the age first. So if they're saying that the age, which is Y, has to be between 21 and 40, I could sandwich my inequality to look like that. Okay, I could also say, sure, your age has to be greater than or equal to 21, but it can't be any more than 40. Okay, so that's what that's really saying. So I want to think the same thing for the height, but I can't do my height in feet and inches. So I would have to kind of write it all out in inches. So for 5 feet 4 inches, I'm just going to kind of put that together. Okay, and same thing for 5'11". Okay, I'm going to do that all as inches. So what is that telling me? Well, that's saying that the height has to be between 64 and 71 inches. So that means I'm sandwiching in between those two. Okay, which is like saying, well, your height can't be any more than 64 inches. I'm sorry, your height has to be over 64 inches, but it can't be any more than 71 or you won't fit inside. Okay, so we're going to graph this now, and I'm just going to move my x-axis up a little bit here so that we can see as we label. All right, so on the x's, I'm going from 64 to 71, so I'm definitely going to use a break here, and I figure I'll just start at 62. Okay, and I can fit all of that. Now for the age, I'm going to use a break as well, but I think I'm going to go by 2s, and hopefully that might not fit. Maybe I'll go by 5s. All right, so I'll start at 20, and I'm going to go by 5s. Okay. All right, so remember that y equals equations are horizontal and x equals are vertical. All right. So I have x equals 64. It is a solid line because it's equal to. And I have x equals 71. Okay, so it has to be greater than 64, which means my arrows would go to the right. And we have to be less than 71. Okay, so my arrows should go left. And for my age, so here is 21. Okay, a solid horizontal line greater than, I want to be above the line. And here is 40, solid again, less than puts me below. Okay, so where is the region that all of my arrows point towards each other? Because that is the shading that I want. And that's this little square rectangle in here. Okay, so any combination of height and age that fits into that square would be, that rectangle, would be a solution for this system. Okay, so I don't think that the traditional graphing of the two equations, the two inequalities, is a problem for you. I think the main part of this lesson here is the word problems. Okay, so we're definitely going to be doing more practice with that in class. All right, but just at this point in time, you want to make sure that you get all of these notes completed and write down any questions that you have. All right, guys, I will see you next time. Thank you for watching.